Let's get it going. There we go. Check the stream. We are streaming. Sick. You know what I haven't done yet? I haven't done the stream resolution thing. It keeps giving me warnings about lately. But we're kind of on a time crunch this morning. I gotta get to jiu-jitsu here in a little bit. So we're gonna focus on cable management, right? Okay. Got our notes. Got our coffee, because it's very early in the morning. We got our stream and everything set up. Let's go. Let's get some work done. Y'all can't hear the music I'm jamming to right now, but excuse me while I vibe. Okay, so that EDA 4 journal, or EDA 3, sorry, I finally got to it. I started doing some stuff with it. It, just like EDA 2, very quickly turned into statistical soup. And so I realized I kind of I didn't really skip some steps as much as I did some stuff out of order. And I want to say 60% of that's on me from when I went through the course material the first time. I guess I could have taken my time a little bit more, but it was also really hard to get it all done in the time that I did get it done. So Flatiron was really good at teaching how to program these statistical methods, right? But they might be really good at it, but they didn't necessarily go very deep into the theory and the real math behind it. Whoops. So it's I have at the end of the module when I started, or the phase when I started the project, I felt well, I have all these tools here, but I didn't really understand how one tool follows the other, in what order to apply them in, and that sort of thing. What kind of questions you should be asking, things you should be thinking about when you're making a decision of which tool to use next and why and on what and how and when and all that stuff. I say it's 60% on me because I wish that would have been in the course material a little bit more, but I've been attending the events more, the Zoom meetings and stuff, the office hours and that sort of thing. And every time I go to one of those, I always leave feeling 100% more prepared to continue on with the project. So I should have been doing a lot more of that all along, frankly. Yeah. But anyway, you'll notice my import cell is drastically leaned out. I imagine we're just, obviously there's no stats models or anything in here yet. And, well, actually here in 2 seconds we're probably about to have to import some stats modules. Yeah, a lot of this stuff right here. But let's go over what I did last night first. So I kind of just decided to more or less throw out this CSV file that I made based off the original CSV file. This KC house data is the original CSV file. So kind of did your typical vanilla pandas CSV import. So I declared my predictors as I just imported all of the file into there. I indexed price from that, declared that as little y. There's a few question marks in square foot basement, and I managed to do something numerical with pretty much all the other NaN values in the data. But I like obviously there's not like 0 square footage out of like. Does the question mark mean there's not a basement? Does it mean they just don't know what the square footage of the basement is? Like, I don't know. And there's only like a handful of them, so of records that have the question mark in it. So I just decided to drop those. And then I'm dropping price from X here because price is now contained in Y, so that's okay. Because you want like your target and your predictors kind of in separate, packaged in separate variables. So here we got some of the square footage, or some of the values in the square foot basement column were strings, I believe. Yeah, they're strings. Oh yeah, I put it right here. And so you just kind of iterated through that whole column and turned them all into floating points, because you can't do ints because some of them have decimals. Grade raws. What is this? Okay, so the grades were like listed in like strings, and it would have like the number of the grade, but then like a string explaining like what that grade means. So it might have 5 and then like average or very good, or like some word, right? Those words don't really matter. Like the numbers are really like the only thing that is useful for the linear regression model. So that's all this is right here. Is we're just grabbing. So we're excuse me. So this is a list of all the unique values in that column, in the grade column. And so we're iterating through every single one of those unique values. So we're hitting like all of like the 5s and all the 4s at like once when we go through this for loop. So we iterate through that list, right? And then we call replace on that value that we're currently iterating through. Whoops. And we replace it with the first index position of that string, because luckily all the strings were formatted the same way. That also the very first character, the index position 0, was the number. Then so we can just kind of, we don't even have to like pop anything or like remove anything or whatever from the string. We can just like index that first position and turn it into an integer right here. Real easy. We do it in place true because we want it to affect the actual data frame. Yeah, and this dot replace method replaces whatever anything that shows up in the column that is this, right? And so this is for iteration 1 of the unique values here. So after we go through this whole list, we've hit every single possible value in that column, and we've replaced it with the integer version of it. This is similar. That this replace method's doing the same thing basically. The only difference is for condition there was no I can like hear my own voice like in my head. For condition, let me make sure. I'm like all jittery today. Yeah, okay, we're good. I just want to make sure the microphone wasn't blocking the camera. So for the condition column, all the values were one of these strings, like in each record, right? And then there was some null values too, right? Or was there? No, there was not. I guess I'm thinking something else. Anyway, so I created this dictionary. And this dictionary is based off of the data dictionary provided by Kings County, the source of the data. Interesting thing about the replace method is you can just pass in a dictionary there, and it kind of does like the rest of the work for you. Which, now that I'm saying that out loud, I realize there's something else down here that I probably could have used that same technique with. Anyway. So year renovated, had a lot of NaN values. I'm assuming because some houses were just never renovated. Makes sense, right? Because like not every house gets renovated if it's like 10 years old or something, you know. So I just replaced all the NaN values with 0 because 0 is like obviously like means like no, it wasn't renovated. At least any kind of like data person that's reading it, I feel like that would be a fair inference. Um, Especially when you're talking about like houses. If this was like historical data of like architectural sites or something, like you know, like architecture, like archaeological houses, like old huts people used to live in or whatever, then year 0 might actually be like a real thing, right? But that's not the case here. So 0 seemed like it could communicate the idea that it wasn't renovated pretty well, or it just like I mean like if it's still just like NaN, like there was no data ever input ever, then like 0 is just as good basically. Waterfront. So this whole column is like it's either yes or no's, and some NaN values or nulls. So I just turned that into bools to make it a numeric type. Basically, like what I'm trying to do is I'm trying to make everything into floats or integers, not objects. So no strings, no date time objects or like anything like weird like that. I want everything to be numbers, right? Because you need that for your linear regression model. Otherwise, it just won't take in the data. So, like I said, there's a lot of NaN values too. So what I ended up doing is just anything that says yes, I'm just making it a 1, and then anything else, literally everything else, if it says no or if it's NaN, then it's 0. Okay, because like if it's NaN, then like it must not have a waterfront, right? I'm assuming that's probably like whoever was inputting the data like was like, oh, it doesn't have a waterfront, so I'm just not going to put any data in here, and so it turned to a NaN value instead of like a no. So now that I'm looking at this, so you can see what I did was I turned this into a string, iterated through the whole column, turned it into a string. If you do this right, this string should be the same length as like the column, and then you can just replace this column with like that string data. But now that I'm looking at it, I feel like I could have done... Oh, no, I'm remembering why I didn't do the dictionary method like I did with condition there. Because there's NaN values, and the dictionary wouldn't catch any NaN values. So, yeah. So we turned waterfront into a bool. So 1 means yes, it has a waterfront. 0 means no, it does not. Or it was a NaN value, which basically is the same thing. This is the one that I was thinking about. So the reason I didn't use like the dot replace method here, like I did with condition, is again because there's NaN values. So I needed this like if else block. So I created a dictionary. So this was weird. We had like some records that had the string none in them, and other records that were just NaN values, nulls. For those of you who don't know, NaN mean it's NaN, not a number, so it's a null value. But it's a NumPy object data type. Versus some of them were just like the string none. So that's why I had to do this if else block instead, or this if else block right here. And so what I ended up doing is I made this dictionary, and I said, hey, for every value in this column, if the value is in any of these keys right here, so you see I called the dictionary but just the keys, and I made it a list, so we're iterating through this list, or sorry, we're in if blocks, we're not iterating through it, but it's looking to see if this value is in any one of these 5 strings right here. And if it is, then we're appending this list right here, which we instantiated, is an empty list to begin with, just like we did up here. We're appending the value into that list. But how we're doing that is we're using the string as the key to call in the dictionary like the number value. So value is like the string, right? In a dictionary, when you plug in, so they're like the keys in this dictionary. So say if it's like fair, then it's going to go to this if block and it's going to say like, okay, like that exists in this list. So now what I'm going to do is append this list with this call to the dictionary. So it's going to go like view dict fair, and it's going to find the number 1, and it's going to append that number 1 to the list. And it's going to keep doing that all the way down. If the value does not show up in the list of keys, then it's just going to append 0. So it's treating NaN values the same as none. Which again seems to make sense to me, because like if this is essentially saying like, no, we don't have like the data for this, NaN is like literally the state of not having the data for it. So I figured, we'll just call none's zeros and NaN's also zeros. I'm gonna clear my kernel for a minute. Okay, so this was one of my neater discoveries yesterday. How to deal with the dates has been a doozy for me through this whole project, and as it always turns out, there's usually a very quick and sleek and efficient way to deal with it. So originally I was like taking the date column and turning it into a datetime object, and then I had like 2 other columns I extrapolated from that with like the year that it sold and then the day of the year that it was sold, right? That was a lot, and also like then you basically have like 3 columns now that are all representing like the same data, which clearly leads to multicollinearity. So what I literally did was I just Googled best way to use dates in a linear regression model, Python. And I found this on Stack Overflow, and I talk bad about Stack Overflow quite a bit, I know, but like I said, this is like that 5% of the time that actually came in clutch. So all this is I also didn't realize, or I forgot rather, I've used it before. Pandas has a to date time method, which is a lot easier than doing something like this where you iterate through the list and then replace it and everything. You can do all this sort of stuff like in one line of code, basically. So convert everything in the date column to a date time object, right? So it's its own data type now. And this is what was really cool to me, is I mapped the whole column to this datetime method toOrdinal. And what toOrdinal does is it takes in a datetime object and it converts it to an ordinal type of value. So an ordinal type of value is like, it's a numeric ranked value. So like even like this view rank list where it's 0, 1, 2, 3, 4, 5, because like 4 is better than 3, which is better than 2, which is better than 1, so on. Like that's ordinal, right? Because there's an order to it versus like even though like view rank list, that's categorical, it's not continuous, but it's still like an ordinal categorical because there is like some value or ranking to the values. It's not just different. As opposed to if I had data on like what city the house is in, for example, like in Seattle, Forks, Spokane, whatever is, I think Forks is in Washington, I'm not sure. Any given city, at least in this context, there's no real like clear, well, this city is ranked higher or better than the other, like for whatever reason. They're just different cities. So that would be a nominal categorical variable. Um, and that's the thing is like a lot of times, sometimes dates or just any kind of like date or time measurement can be used as a categorical variable. Um, so like if you're talking about cars in like the year model, perhaps, which I mean, you could also make the argument that like newer year models are like better technology. Um, but you can also just like you know make the argument that like well they're just different models. Um, so that would be like an example of some sort of measurement of time being used in a nominal way. But that's not what we're doing here, right? So the date column, by the way, is the date that the house was sold. Um, so we're looking at like how long ago or how recently the house was sold. Um, so anyway, what that does at the end of the day is it takes in your datetime object, turns it into an ordinal value type based on the Gregorian calendar, right? So January 1st of year 1, so first January after the crucifixion is 1, right? And then 2 and then 3 and 4 and so on. And then January 1st of year 2 is 366. So 365 days in that first year plus that 1 day the next year, and then so on and so forth. So you get these really like weird looking integers that don't mean much to a human, but they make a lot of sense to a computer or to a linear regression model. So that's really cool, and that took like what was taking me probably like a dozen or so lines of code and sliced it down to like 2. So that was really really neat. And yeah, you can see I just called like the map. I just mapped this method to everything in the date column, and I replaced everything in the date column with that. Yeah. Null dict is cool. This is I don't. Oh yeah, I haven't ran anything yet, so I won't show you. But this is just a little for loop that I wrote to. It looks at. It counts how many null values are in a given column, and then it adds to this dictionary the label of that column as the key, and then the sum of or the count rather. I'm using the sum function here, but it's the count of null values in that column as the value. So the label of the column is the key, and then like the amount of null values as the value. So that was pretty handy. Which also reminds me, let's digress just for a moment. I made this really cool function yesterday too, which is part of what led me to realizing I needed to kind of like start back from the beginning. So love-hate relationship, but nonetheless, I was really proud of myself to figure this out. There's some YouTube video that really helped a lot figuring this out. So I wanted to see like what the R squared value is for like every individual feature, like like individually, like so how so what this is doing is just doing a linear regression model using price as the predictor, and or whatever you pass in as y, because this is a function that I've declared here, and then you have like some kind of list or array type of data that you pass in as big X here. And it gives you, and it creates a dictionary with the R squared value for any entry in that in the dictionary is the label is going to be, or the key is going to be the label of that column or feature, and the value of that key is going to be the R squared value of just that one predictor and the target y. So I'm doing a multilinear regression model, but it just seemed like a nifty thing to look at as I'm kind of like going through the data. So this coffee is really catching up with me, and I'm gonna have to hit the John just for a moment. So I'll be right back. Man, time flies when I'm streaming. Okay. Sorry, I should have left that unfolded for y'all to check out. Interesting note here. So normally I look at model.summary when I'm looking at the stats model report for like your R squared value and your coefficients and blah blah blah. But you can't really do anything with it other than just like read it like as a human on the screen. So I found this method summary 2, which returns the same info as .summary does, but like as a data frame. So you can index and slice specific values that you want from it. And so that's why I was able to put this in a for loop, is because I was using this .summary 2 method. Yeah, and it just it creates a dictionary. Pretty nifty little function. So let's get back to business. That's good stuff. Okay. So now we are going to investigate multicollinearity before beginning inferred features. And by inferred features, I mean like there's some stuff that I'm engineering, like relative living space, which is the difference of like the square footage of living for like this record and the square footage of living for this record, but the square footage of living column versus the square footage of living 15 column. What that column represents, the 15 column, is these like average square footage of the 15 nearest houses. So I thought it'd be interesting to see, like, because it seems like it would affect the price of the house, like how big your house is compared to every other house on the block. So when I ran this, when I looked at the multicollinearity for all the data before, interestingly enough, it recommended basically, based on the collinearity value, that I drop these columns: square foot living 15, square foot lot 15. If I drop them now, I won't be able to engineer those features. Those like inferred features might end up just being dropped anyway. But I want to see that happen. I want to see them and see like how they stack up in the multicollinearity investigation nonetheless. So while I'm thinking about it, before I do anything else, I'm going to try to share my stream here. Y'all can't see this. I'm posting, I'm sharing to my Facebook real quick in case anybody wants to come join the stream. I want to post that to my story too. Let's make that public. The story. Ooh, I can share it to LinkedIn too. Let's go. in a post. Project, school, data, science. How about Python? What about Instagram? If I can share it directly to Facebook, I ought to be able to share it directly to Instagram. No. That's too bad. I don't have a Tumblr. Nobody uses Blogger. I have a Pinterest, but it's just to like save cool stuff. I wonder if I can copy this link and then go to Instagram.com. Oh no. Okay, the webcam's gonna go out for just a moment. 609. Let me make sure my stream camera is still good. Okay, cool. Go separate ways. You can now create and share posts directly from your computer. That's exactly what I wanted to do. That's not exactly what I wanted to do. I wanted to post to my story, man. Alright, this is what I'm gonna do. I'm about to move the camera again here in a second. I should probably get in the habit of doing this before I start the stream, but this is only like my third stream, so you know, we're learning. We'll get the hang of it. Whoops. Yeah, y'all are still looking at VS Code. Cool, so that's fairly interesting. It's a lot more interesting than my email, I'll tell you that. Unless you're a hacker. That's always a fun conversation. My parents, they always ask me if I can do stuff that's like IT type stuff. Like my dad one time was trying to like get me to figure out how to do some kind of network configuration hoopla with his router, because they live out in the country. They have a hard time getting internet, and he was like, well, yeah, well, I was watching this YouTube video and it seemed pretty easy, like something you could do because you're good with like computers and coding and like whatever. And like, not his exact words, but that was basically like his idea, was that because I know how to code, I must be able to just like manipulate computers at will. Or at least that's how it felt to me. And I was like, yeah, nah, that's kind of outside my wheelhouse. Or my mom, it's always like Excel sheets. Okay, I'm gonna move the camera just momentarily, just so I can share this YouTube link on my Instagram real quick. You're a player, aren't you? And I bet you got hoes. Just 1 second, guys. It's only gonna take a second. We'll get that epic cam back here in a moment. Oh man, we only have just a little while longer to. Let's take a selfie. Let's take a selfie with the coat in the background. Okay. Now I need to add a link. No, not a mention. Not a location. How do I add a link? Hold up. That's a terrible photo. There it is. There's the button. So now we go to our notes. Copy link. Paste the link. Come do nerd stuff with me on my live stream. God, that's a terrible photo. Oh, I hate myself. Not really, but that's better. That's much better. Link, paste. Come do nerd stuff with me on my live stream. Did way too long. Call the good times and stuff. Stance. Sleep and wake up when the world ends. This memories, they so hard to forget. Oh, let me get my background filter thing back on. Cool. Not that there's anything in the background I don't want you to see. It's just like kind of not exciting. Kind of ugly. It's just my bed. Okay, cool. Back at it. And I should probably mention in the chat, because like the first one I did, I had people actually join and they commented and I didn't see it in time. Average view duration 40 minutes 21 seconds. Who, me? There's 0 concurrent viewers, so like weird. Thanks for joining. I check the chat about every 10 minutes or so. Cool. All right, back to work. Like actually, because we gotta get to the gym. Okay. I want to stretch before I go to the gym too. Yeah, so we kind of cleaned up the data and everything. So we'll just go ahead and we'll run everything above this cell. We'll add a new cell here. So that's good. We get no errors. Well, hold up. Nulled it. So as you can see, we no longer have any null values. And you know what? I'm probably going to drop ID too, because it's just like a unique identifier. It's not doesn't really mean anything. So now, oh my god, oh my god. Stop. There we go. Now we'll run all that. And wait very patiently. Because this is a lot of data. It's pretty compute intensive. But not too bad. See, it's running a lot faster than like the first stream I did, so that also probably means my code quality has improved a bit, because we're not getting like 30-second long cells. But we also haven't done any data viz yet, so we'll see when we start doing data viz. Whoops, no. What is it? X dot info. So what I'm looking for here is anything here that says object. And as you can see, nothing says object. It's all NumPy data types. That's why it says int64, not just int, because it's a NumPy object. Which is fine. That makes sense. Like anytime you're dealing with any sort of like array type data, like a data frame in Pandas, I'm pretty sure Pandas is built on top of NumPy or with NumPy or whatever. So this is good that everything is an integer or a float. Okay. I'm looking for, yep, correct amount of entries. I don't know what that means. 19 columns, blah, blah, blah. Yeah, so we'll look at what the correlation is there. So according to this, basically the idea is, and the reason I'm doing 70 here, not like 75, is because there's like 19 features, and so like even if I did like 65, it would probably give me a little bit more. But you don't want to do too much, because it's too much. Let me look at like 60 though. That might make that my threshold, because when I went from 65 to 60, it didn't change much. So according to this, you basically want to drop like one of each of these pairs, because these are the most correlated features in the data. Which, so you can think about this as meaning like 88% of these values represent the same information as these values, or they predict the target with the same reliability. So you don't want both of these being passed in your linear regression model, basically, because they represent the same data, and that's going to skew your statistics. So I would rather know about the square foot of all the living space rather than just the square foot above grade. So this is everything that's like not the basement, basically. Because maybe you have like a really cool man cave in your basement, and then that would be included in your square foot of living. right? Um, so this is kind of a great example of where, like in data science, where it matters not just like your programming and your math skills, but also like your understanding of the business that you're doing analysis for. I have all this creamer on the edge, and I don't want to like waste it. Um, so anyway, yeah, we don't have anything below 60, so I might start using that as my threshold actually. So we'll drop square foot above. Square foot living is also here. It's also highly correlated with square foot living 15, which makes sense because I can't imagine that the house is like the square footage of the living space is that different from like the other 15 houses around it. So I'd rather know about the house itself than the houses around it, so we'll get rid of that one. Based on remember, this is before we like look at our inferred features. So bathrooms, that was weird to me that square foot living and bathrooms are so highly correlated. But it also, like, I don't know, my thing about it kind of makes sense because the more living space you have, the more bathrooms you're gonna have, and so it makes sense that they would kind of approach the target variable in to the same like degree or magnitude, whatever. Square foot lot 15. Yeah, so by the time I got here, I'm already planning on dropping both of these. So, went ahead and plugged in bathrooms, and again, it's kind of same logic here as here. I would rather know about the lot itself than the other 15 around it. So I'm gonna drop lot 15 and keep lot. And then we're already planning on dropping both of these anyway. So the fact that we went from 70 to 60% of a correlation threshold doesn't actually affect which features we actually want to drop. So that's good news. So now we're going to do the same thing. We're going to investigate multicollinearity, but after we add our inferred, or engineer rather, our inferred features. Because I'm a data engineer. I'm trying to be a data engineer. One day. When I get paid. When I start getting paid for this sort of thing, then I can call myself a data scientist or a data engineer or whatever. A professional nerd. I use nerd like derogatorily, but I also like call myself a nerd all the time, so it's okay. When I'm gaming online, that's like my favorite thing. Like especially when like some little kid starts like, you know, schooling on the mic or like just talking smack to you or whatever. It's like, shut up, nerd. No one asked. But then here I am calling myself a nerd all the time. So it's okay. It's okay. Shout out to all the nerds out there. Just not the 12-year-old dorks on Xbox Live. Nerds. So anyway, this is just kind of explaining what each of these engineered things are. I'm gonna try to get these all kind of like on the same level with each other. It might make it a little more readable. That did nothing. Okay. Well, at least here I just won't run this cell. So bed bath ratio is the ratio of bedrooms to bathrooms. Again, this kind of the original multicollinearity investigation suggests dropping bathrooms, but I want to see what this ratio might look like first, because that kind of would be interesting, right? Like, because also if a house has 5 bathrooms and 1 bedroom, that would make it less attractive to me as a potential buyer. So I would think that would affect the price in some way. Level ratios is the ratio of square footage above grade to below grade, right? So square foot of living versus square foot above versus square foot basement. Live lot ratio is the ratio of living space, square foot living to square foot lot. So the square footage of the size of your house to the size of your lot. Relative living space is the ratio of square foot living to square foot living 15, right? Because that's interesting to know. Like, how does your house compare to the other 15 houses? Again, the original multicollinearity investigation here suggests dropping square foot living 15, but because that alone basically represents the same information as square foot living, at least in a mathematical sense. So, but that ratio, the relative lot size or relative living space, might represent something different. It might be a better predictor than just square foot living alone. I don't know, but it's worth investigating, in my mind at least. Relative lot size is the same thing as relative living space. It's just for the lot instead of living space. And level difference is like a level ratio, but it's just the difference instead of the ratio. So it's like square foot above minus square foot basement instead of square foot above divided by square foot basement. So this is just where I'm creating all of these variables, and they all kind of follow sort of the same ideas. You just create a list with where every record is like the math. So this is like BB ratio equals row dot bedrooms times row dot bathrooms, and we're iterating through like every row, and then you just append that to the list, and then down here you assign this list to this new column feature. And so creating a new column in Pandas is a lot like creating a new key value pair in a dictionary. Is you just write it right here. Like, it doesn't have to exist at all. You can just do like the name of your data frame, square brackets, and then the name that you want the column to be, and then equals like whatever data you want plugged in there. It does have to be the same length as everything else in the data frame, however, so you do have to make sure that if you do have any like null values or anything, that you put zeros or nans or something in there to fill up the space, because otherwise you're going to get an index error. That's why I dealt with all the nulls and nans beforehand. I keep saying nulls and nans, but they're literally the same thing. So whatever. Same thing here. The logic here, whatever, is I have like all the ratio column feature engineers. Everything that's a ratio is in this cell, and everything that is not a ratio is in this cell, which I guess relative living space and relative lot size is technically a ratio. Or no, it's not. It's the difference. Yeah, it's the difference. So anyway, I'm tempted to get like the difference and the ratio, but it's probably just it's gonna be multicollinear. It's gonna be the same information, so that's probably more work than it's worth. So we're going to run these two cells here. Wow, I was bragging about my computer running so fast a minute ago. Cool. That wasn't too long. It's 11 seconds of my life that I'll never get back. Cool. Check the chat real quick. Nope. Cool. All I see is red and white. I gotta figure out like what the rules are around like playing music like on streams and stuff. Cause I'm over here jamming, just bopping my head. Y'all it's just like silence on the stream end. But I'm having a good time, so it's okay. So yeah, so like here we can just check that those columns did get successfully made. We can even do x.info if we want to, just to like check out, make sure we don't have any objects or anything, which Okay, I got someone knocking on the door. I'll be right back. Alright, sorry about that. So anyway, as you can see, there's no, like, we don't have any objects or object types or anything. They're all floats and ints, which makes sense because they were made from floats and ints, right? So I'm just gonna comment that out just to get it out of the way. I like doing that a lot for like stuff like that where it's just like a check. I'll just like comment it out so I can just uncomment it and run it and then whatever. But I don't like to leave it there because it's just like a lot to scroll past whenever you're doing stuff. So now I'm gonna reduce that threshold again because we discovered earlier that 60 is probably an appropriate threshold. We got a lot of features here, so it doesn't hurt to trim a lot of fat. Cool, that ran like lightning. So now we're gonna go through here and we're gonna find which features we want to drop based on. I'm streaming right now. I hope you don't mind. Okay. So we're gonna find which features we want to drop based on their multicollinearity, and again, the wisdom here is that we want to drop one of each of these pairs. So we're just gonna go through here and kind of manually write down a list. I don't think he's home. So anyway, the wisdom here is that we want to drop like at least one of those, and like we saw earlier, some of these pairs might be a pair of two that we're already planning on dropping. So that will simplify things a little bit. So this first one here makes sense. Level difference and square foot above are highly correlated, and that's good to know. And I see that square foot above, I already immediately see square foot above is also highly correlated with square foot living, which I'm pretty partial to square foot living. I really want to keep that feature in there. That's my assumption, would be that would be probably our strongest predictor. We'll see. But so I'm going to drop square foot above and keep level difference. So I'm going to create two lists here. Code keeps and code drops. So I'm going to keep level difference here, and I'm going to drop square foot above. And I see that we already dropped square foot above, so I'm going to keep square foot living. I say we dropped it. We haven't actually already, but we're planning on it, so you get what I mean. Square foot living. We don't have to add anything here because we already have square foot above there. Square foot living and square foot living 15 are highly correlated, so we can drop square foot. I gotta make it a string. Square foot living 15, because again, like I said, I really want to keep square foot living as much as possible. Bathrooms is highly correlated with square foot living yet again, so Uh, Now we look at square foot lot and relative lot size. So I want to see if either one of these show back up anywhere down here before I make any decisions there. So we already dropped square foot above and square foot living 15, so we can just kind of ignore that. Square foot lot and square foot 15 here. So we got, that's 2 for square foot lot. Let me go. I think I want to drop square foot lot 15 here. That's probably fine. And see, now we can drop any of the stuff that the inferred features are inferred or extrapolated from, because those inferred features already exist and we have that data. So we can drop the columns that they came from. We still have to keep that data. We don't lose it because we ran all this stuff like in place, right? So square foot drops. Where were we at? Square foot lot 15. This is the one that we're still kind of unsure of. So square foot above and bathrooms. We already dropped square foot above and bathrooms, so we can just ignore that. Square foot living and relative living space were highly correlated. Ugh, that kind of breaks my heart because we got to get rid of one of them, and I'm already like partial to square foot living and relative living, or square foot living, as much as I want to keep relative living space. Our threshold is also only at 60%, and if we were doing like 70%, which is kind of like the sort of like standard or default, if you will. Okay, so this is good news. Bed-bath ratio in bathrooms are highly collinear, so we already dropped bathrooms, so we can keep bed-bath ratio. This is completely an ego thing for me. I just like the more of like my features that I came up with, that I like the inferred features that we can keep, like the better, because I'm just like, yeah, I did that. I came up with that. Oh man. Okay, so this is what I'm thinking. I only see relative living space in here once, all right? And I see square foot lot in here a lot. Like 1, 2, 3, 4 times. So as much, I haven't been keeping up with this list at all, have I? As much as I really like square foot living, apparent relative living space is representing essentially this, predicts the target to a similar degree. So I'm tempted to drop square foot living in lieu of relative living space, because square foot living is so collinear with so many other features. I think we're going to try that. We can always go back and change it. So that's what we're going to try. That's it for the coffee. Starting to feel that buzz too. Yeah, we got maybe 20 more minutes on the stream before it's a wrap. So we're keeping, what did I say, relative living space? it kind of breaks my heart. Excuse me. I guess I really don't need co-keeps because, like, once I drop this, then obviously the complement's just going to remain anyway. So we're dropping square foot above, we're dropping square foot living, we're dropping square foot living 15, we're dropping bathrooms. Oh yeah, we hadn't made a decision on this one yet. Because we're dropping square foot living, I think we're going to keep square foot lot and drop relative lot size and square foot lot 15. So then at least we have some kind of square footage measurement of the house itself and not like some inferred something or another. So we're going to drop relative lot size. Man, I wish I could play music so I could jam with y'all. Okay, so we dropped relative lot size here. We're already dropping both of these anyway, right? Yep. We're keeping square foot lot and dropping lot 15. We already dropped above. We already dropped bathrooms. We're dropping living, square foot living, and we're keeping relative living space. And we're going to keep bed bath ratio because we already dropped bathrooms. Okay. So, just to drive home the point, we'll go back up here and we'll look. I just want to try to match up like the pairs here. And I could code this, I guess, but okay, cool. So, essentially what we found was we wanted to drop all those same ones that we suspected to drop earlier. Only now we're going to also drop relative lot size, which wasn't there in the first place. And we're going to drop square foot living because that's also represented by relative living space. Which, like, okay, let me Google real quick. How much collinearity is too much? A rule of thumb regarding multicollinearity is that you have too much when the VIF is greater than 10. This is probably because we have 10 fingers, so take such rules of thumb for what they're worth. But that's not... Big reveal. I'm Pickle. I'm Pickle Rick. Pickle Rick. Pickle Rick. Okay, so I can look at like what the variance inflation factor is, I guess, for that. I don't really... I didn't want to do that yet, but we will. I have a function here somewhere for... Yeah. I like to keep all my functions and everything declared like right at the very top. So like imports, function declarations, variable declarations, then like stuff. Oh yeah, what? I didn't copy the whole function. Come on, VS Code. You're supposed to be smart. Smarter than me. Feels like that sometimes. I'll tell you what. I tell you what. In the maze where I find only got one shot to get it right, 'cause I won for me, swore an oath, more money, overdose, or outside, alright, gonna see us falling overboard. Come over, bring your best friend, let's head back to shore. Come on, stats models. Okay, so I'm going to look strictly at the variance inflation factor. Of let me make sure I get this index call right. We're looking at square foot living and relative living space. Come over, bring your best friend, let's head back to shore. I don't think it's gonna work. Oh, it did work. Cool. So we can pass that into create vifdict. Okay. So the various inflation factors here are essentially identical, but what if I don't know what all this is. Huh. Relative living space. Inf. So there's no really good indicator here of like which one to keep or drop. Other than the fact that I'm seeing square foot living show up as in, and these are not all just like all the collinearities of everything, right? This is like the anything that has a collinearity factor between 0.6 and 1. So highly collinear features. So these are our 1, 2, 3, 4, 5, 6, 7, 8, 9. What, like, you know, a dozen like most collinear pairs, right? Not features, but pairs of features. So this whole block here goes through like every possible combination, basically. So like I could call core DF and it would show me this for like every combination of pairs. So the fact that I'm seeing square foot living show up a lot, like multiple, like 4, 5 times or whatever. Yeah, 1, 2, 3, 4, and relative living space only shows up the one time. Tempts me to keep, and the fact that the various inflation factors like alone are about the same, and the various inflation factors everything else are astronomical, but it's still the same. That's the only thing I can see to use to like make a decision. Is that square foot living is clearly multicollinear with a lot of things, and relative living space is only multicollinear, highly multicollinear with square foot living. So, yeah, we're just gonna have to drop square foot living. Cool. So let's go ahead and run that. Just kind of cleaning up everything so it's easier to scroll. So now we're gonna do x dot drop co-drops axis equals 1 because we're dropping columns, not rows. Axis is 0 if you're dropping rows, but that's also the default. So if you're dropping rows, then you don't have to pass that in. Just to make sure this is doing everything right. We're probably still gonna drop end up dropping zip code and latitude and longitude and whatnot. You know what? So there is a way that I can map zip code to the waterfront, figure out exactly which waterfront it's at. But there's hardly anything with a waterfront. There's so little data. So if all of the houses were on a waterfront, that would be useful, but there's not. And I could do a similar thing with view, but it wouldn't be quite as accurate because it tells you it gives you a list of view means you have a view of one of these places. So I could find the zip code of those places and map that to the zip code of the record, and then create a feature that shows which place it has a view of. I could do that with latitude and longitude too. So I'm just gonna leave my. It's about time for the stream to end. So I'm going to just leave some notes here for me. Okay, investigate mapping zip code or coordinates to view, because I tried that before with Waterfront and it just didn't really yield a whole lot of data. There's only like 4,000 or something like records that were actually on a waterfront. And the fact that we have like a bool for waterfront, like yes or no, is like a good predictor, I would think, like on its own. Okay. So I got to get to jiu-jitsu practice, but we got some good work done today. Whoa. My boss is calling me. Let me. Okay, that was my boss calling me. Just in time for me to get off the stream. So yeah, that was some good work. We avoided a lot of hard coding that we were doing earlier, so we'll go back. We'll come back later this afternoon and check out this stuff right here. Cool. So